Hello Year 5, welcome to Monday's maths session where we are looking at can I add 3 fractions. So last week we were doing some work on adding fractions. Can we add 3 all at once? That's what we're going to explore today. But first off, here is your arithmetic starter. Now it looks a little bit different now. I've got 4 questions for you to complete. How will you manage it? So have a look at this one, number 1. I want you to answer it without doing the calculation. Okay, that's your challenge there. And then number 3, can you work this out without having the square drawn to help you? What knowledge do you have about squares that might help you out with this one? Okay, pause me here, have a go, and then I'm going to show you the answers in 3, 2, 1. There we go. How did you do? Will 865 have a remainder, divided by 5, have a remainder? No, of course not, because it must be a multiple of 5 because it ends in 5. Okay, and did you manage to work this out using your knowledge that a square has 4 sides all the same size? Wow. Let's get cracking with today's maths. Okay, here's a warm-up for you. Can you complete the sequence of equivalent fractions? Now remember that whatever we do to the top, we've also got to do to the bottom. Can you work out what is the sequence here? What are we jumping up each time? Okay, have a look at the numerator, have a look at the denominator to help you out. And I'll give you a top tip too. This one, it seems pretty simple. You've got your numerators going 1, 2, 3, and you've got your denominators going up in the same jumps each time. But what about this one down here? We go 1, 2, 4, and then we go 2, 4, 8. Can you work out what is happening in this sequence? Okay, can you fill in the remaining lines of my sequence? Pause me again, and then in 3, 2, 1. There we go. Those are the answers. Did you spot the sequences? Did you get them correct? Are there any cheeky, marvellous mistakes that you need to correct? All right, hopefully your brains are nice and warmed up with fractions. Let's go on to today. Now this is an addition question, which has 3 fractions. We've got 3/16, add 1/4, add 1/2. Now, what do we know that we have to do when we are adding fractions? What do we have to remember? We have to remember that our denominators need to be the same. So exactly the same way that we would with a normal addition with 2 fractions, we need to make sure that all 3 of our denominators are the same. Okay? Can you think of a matching denominator that all 3 of these can become? Hopefully you've spotted it, and if you haven't, maybe count how many parts I've got in my bar model down here to give you a hint. We need to make them into 16ths. So how can we get from 4 to 16th? What do we need to do? We need to times it by 4, because 4 times 4 equals 16. Okay, let's see if I've got that correct. Yes, here we go. So I've times it by 4 and I've got 4/16. What do I need to do with my half to get to 16? Well, I need to times it, and it's going to get bigger, isn't it? So it's going to be times by 8. Okay, let's reveal that one. And that will be 8/16, 8/16. And then what we're going to do is we're going to put it into a bar model here. Okay, so I've got my original 3, 1, 2, 3. I've got my 4 here, 4, 5, 6, 7. And I've got my 8 added on. 8, 9, 10, 11, 12, 13, 14, 15. So altogether I have 15/16. And then I can check that by adding 3, 4 and 8 all together, which gives me 15/16 or 15/16. So it's exactly the same as adding our fractions. We just have to remember that we need to make all 3 denominators the same. So remember, I'll change that colour in a minute. Remember, all 3 denominators must be the same. Oh, we're going on a journey. There we go. All three denominators must be the same. Let's change that to black so you can actually read that. There we go. Okay, so using the same method, have a go. It's your turn here with this one. You've got 2/5 plus 6/10 plus 4/20. So which way are you going to change your denominators? Are you going to make sure they all have the same denominator? And which denominator are you going to pick? Because actually, there's a couple of options with this one. Which way are you going to do? Pause me here, and then I will reveal the method that I used. In 3, 2, 1. Oh, wrong one. There we go. This is the method I used. I decided, right, I'm going to make them all have the denominator of 10. So my bar model is going to have 10 parts in it. So this one, 2/5, I had to times by 2 to give me 4/10. And then 4/20, I had to divide by 2 to give me 2/10. And then I put it all together in my bar model. I've got 10 parts on each line. I've got my 4/10, add my 6/10, add my 2/10, and that gave me 1 whole and 2/10. And that's why I've ended up with a mixed number, because it's greater than 1. I hope you're following. Don't forget, you can always pause, go back and listen to an explanation again. All right, now here is a sneaky word problem. I know you guys smashed your word problems last week because I saw lots of you emailing me work, which I really enjoyed. So what do we need to do to solve this word problem? Well, we need to remember our rucksack, so we need to highlight that important information. Let me get my highlighter out. Danny eats 3/14 of a cake. Stacey eats 1/7 of the same cake, and that's important because it's the same cake. Albert eats 1/2 of the same cake. How much of the cake is eaten? Now it's the same cake, so there's one cake that we're talking about here. That's why it's really important to highlight that word same, so we don't get confused and think they've all got their own cake. What do you notice immediately about our denominators? We've got 3/14, 1/7, and then 1/2, which is also represented like this. Can you think of any denominators we can use that all three numbers are going to go into? Well, if we keep this one 3/14, we should be able to make this one something 14th and this one something 14th. How are we going to do that? Well, I'm going to use my part whole model to keep track of my numbers. So I'm going to put 3/14 in here straight away. There we go. Then I'm going to take 1/7. I know that 7 times 2 is 14, so I'm going to have to do 1/7 times by 2 equals 2/14. There we go. There we go. I'm going to put it up here as well. 2/14. There we go. And then we do the same with 1/2. Am I going to times by 2? No, because that won't get me anywhere near 14. I'm going to do my half times by 7, because 2 times 7 is 14. So I'm going to times that one by 7, and that should give me 7/14. There we go. Right, now I've got my part whole model, and I've represented how much each person has eaten of our same cake. Remember, it's one cake that we're talking about here. So what do I need to do now? Well, now I need to add together everybody's portion of cake. So I know that my denominator is not going to change. There are still 14 parts. I'm now imagining 14 slices. So how many have I got all together? There we go. I've got 3 plus 2, which is 5, plus 7, which is 12. So now I know that altogether they ate 12/14 of this cake. But am I finished? Nope. I've got to simplify my answer down. How can I simplify my answer? Well, they're both even numbers. The first thing I'm going to think of doing is I'm going to divide them both by 2. So that is going to give me, not sure what happened there, 6 sevenths. And that is how much of the cake is eaten. Now that has told us how much Danny, Stacey and Albert have eaten as a fraction and as a simplified fraction. Okay, let's move on. Okay, this one's for you. Pam and Mick are adding 3 different fractions. Pam thinks her answer will be the biggest fraction. Do you agree? Is she correct, and can you explain why? I want you to use APE, which is our answer, our proof, and I'll explain with some very weird handwriting, Miss Rutherford. Answer, proof, and then explain it, please. Is she correct? So Pam is adding 3 24ths, 1 quarter, and 2 eighths together. And Mick is adding 1 quarter, 1 half, and 4 24ths. Who is going to be correct? And I'm going to reveal the answer in 3, 2, 1. Pam is incorrect because 22 over 24 is more than 15 over 24. Remember that if our denominators are the same, then the bigger the numerator, the bigger the fraction. Okay, here is some varied fluency for you to do today. Now there are additions of 3 fractions for you to crack on with. And then if you're feeling super confident, I have a number square challenge for you. What you need to do is you need to work out what the missing fractions are to make sure that the total of each column and each row is 4/5. So this missing number will make this row equal 4/5, and this missing number will make this column equal 4/5 as well. Can you work out what the missing numbers are? It will require a little bit of engaging your brain in gear today, but that is your spicy challenge. Okay? And then head over to the website where you will find today's reasoning and problem solving. I hope that you crack on really well, but don't forget that you can come to a daily drop-in session if you've got yourself in a muddle or you keep making some marvellous mistakes. Let's demystify those together. Okay, I'm going to show you the varied fluency and challenge answer in 3, 2, 1. There we go. And here's the challenge. If you haven't done the challenge yet, quick pause me. All right, did you manage to get these? Now these are in its simplified forms. I will also accept them if you've gone crazy, as long as they are all equivalent to the numbers that you have given me here. All right, guys, have a fantastic Monday maths. Bye.